Hello! Congratulations for being introduced to the first worldwide, freely accessible database consisting into complete verification projects. Each verification project consists into a circuit design written in Verilog or System Verilog language, into a verification environment which can stimulate the circuit and can check its correctness. The verification environments are written in System Verilog, and some of them follow UVM methodology. And both resources are well documented into steady documentations which describe the functionalities, the verification plan, the assertions, and other things related either to the design or to the verification. To the knowledge of the authors, this is the first worldwide freely accessible database, which is useful for at least two reasons. One, it can serve for learning. The verification students or verification enthusiasts can learn verification principles by looking to already done projects which can be completed with other tests. And second, the verification projects can be used as benchmarks for automation approaches of verification. We know that nowadays there are many verification approaches for automation. We use reinforcement learning. We use genetic algorithms. We use supervised and unsupervised learning to close the coverage for the verification projects, to generate stimuli to reach different scenarios, and to check that even in the corner cases the DOT operates well or not. This is the main page of DaVe database of verification projects. It contains several projects and more projects will be added. All the projects contains the documentation, the digital circuit to be verified, the verification components which can be run in order to stimulate the DOT functionality, the top file and interfaces which are used to link the verification environment with the DOT. The specification, one of the strong points of this database, contains a section for the design, digital design of the circuit, consisting its functionality, and the digital circuit verification, containing the verification infrastructure and details about it. In the digital design of the circuit, the first section, you can see the block diagram of the DOT, the general functionality description, the DOT interfaces, the protocols which are used on the interfaces, the DOT functionalities listed in detail, and different schematics which can help engineers and verification enthusiasts to understand the functionality of the DOT. Also, the table with registers, some waveforms, and the section for digital circuit verification contains the schematic with the verification infrastructure. Here you can see that the verification environment is written according to the UVM methodology, and you have after that each component described. Besides documentation, you find files with interfaces, you find the RTL code, you find the top file, the test bench, called here. You find tests. You can write more tests based on these examples, and you can find all the verification components. In this way, verification enthusiasts, verification beginners can learn good principles of verification, having projects which are fully operable. Also, verification engineers can test their automation approaches in verification. One of the most approach automation in verification is to close the functional coverage. That can be done having a verification environment and creating different stimuli until coverage is 100% done. Machine learning, with all its branches, has a very big potential to help in verification automation. You can take the verification environment, insert a wrapper, an automation layer written in Python or in another language, and embed this verification environment or another in order to test the efficiency of the verification approaches. And using these duties, the community of verification engineers will be able to compare their approaches in order to see which works better and which still needs improvement. You are kindly invited to access the freely accessible database DaVe, which will be useful for both verification learning and for testing automation approaches in verification. You can run with a single click the verification tests in order to check their functionality. This feature will be available soon. Stay tuned.